Hi everyone. Today we're going to begin our in-depth look at the 4 conic sections by looking at the circle. Now, if you have not watched Mr. Nash's Intro to Conics video, I strongly recommend that you do. He talks about where the 4 conic sections came from, and he also talks about what the graphs look like and how different values in the equations of the graphs affect the way the graphs move and how they look in size and shape. We're going to be going into detail with each specific conic. We're going to look at first the circle, we're going to look at the 2 forms of its equation, and we're going to look at how different values affect the way those conics look. So let's start out by talking about the general form of all conic equations. This was not mentioned in Mr. Nash's video, but I do want to mention it here. So every type of graph has an equation and the way the equation looks. And different values in front of different letters affect the shape and size of the graph. So the general form for all conic equations is this formula here. Capital A, x squared, plus c, y squared, plus capital D x plus capital E y plus capital F equals 0. All the coefficients on the x's and y's are capital letters. Now as you write that down, you're probably thinking, Miss Bell, you skipped B, and yes, I know I skipped B. There is a B term that we tend to leave out at the high school level. It is a capital B x y. And it is rather complicated. It takes those conic graphs and it rotates them around their center point. So they're a little bit skew. And that's, as far as the algebra is concerned, it's a lot more complicated than we are going to be showing you right now. You may go into more depth if you do study maths at university. Now, what makes a circle's equation fit this form? For the circle, A is going to equal C. Whatever A is, C is the same number. And they are usually both equal to 1. So in most of the homework problems here, you're going to see A and C both equal 1. So you're just going to see x squared plus y squared, and then the rest of it. All right, so let's talk about what exactly a circle is. What is the definition of a circle? Well, there is a tool that you may have used before that you can draw a perfect circle with. Do you remember what the name of that tool is? That tool is called a compass. Now, it's not the compass that tells you what direction you're moving around, either tramping or kayaking or whatever. This is a compass that draws circles for you. And the way it works is you have a fixed point that you put in the spot where you want the center to be, and then you rotate the outside around and it makes a circle. So the definition of a circle is the set of all points that are the same distance from a fixed point. It is the set of all points that are the same distance from a fixed point. Those 2 things that are referred to in here have special names. The distance we're talking about and the fixed point we're talking about. The distance, what do you call the distance out from the fixed point? It is called the radius. And the fixed point that you measure from is called the center. Now, in all other geometry problems that we've done, what letter have we always used for radius? The radius is always R. Now, the center we're going to use as H and K, lowercase for both, H and K. That is the standard from the knowledge that I have, the way we learned it in the US, for using those for the center point, H and K. H is the X coordinate of the center, K is the Y coordinate of the center. Okay, so how does this look graphically? If you have a graph of a circle, I have a tool that makes perfect circles. Let's do that. There we go. The center point would probably be right about here. That point's coordinates would be H and K. And the line that goes out from there to the edge of the circle, that's R. So that's graphically how it looks. Okay, now there are two forms of every conics equation. The two forms of the circle equation. One form is what we call the general form, and the other form is the graphing form. We're going to look at the general form first, because I've already introduced it briefly at the top. Number one is the general form. It is x squared plus y squared plus dx plus ey plus f equals 0. Now, if you needed to know the center or radius from that form, it's kind of difficult to find. So what we have to do is take something in general form and change it to graphing form, which uses different letters and looks slightly different. The graphing form is x minus h, the quantity squared, plus y minus k, the quantity squared, equals r squared. And once again, the center here is h and k. Now, I want to point out to you, notice that both parentheses say minus. That is very, very important. If you see x minus 2, the quantity squared, the center is at positive 2. If you see y minus 3, the quantity squared, y plus 3, the quantity squared, the y coordinate of the center is negative 3. What I tend to tell my students to help them remember is the phrase that insiders lie. Now that sounds kind of strange, maybe, but anytime you see a value inside of a parentheses, like here or here, when you're pulling it out to find the center or a vertex, it's always the opposite sign of what you see. If it's inside the parenthesis, it lies about its sign. And the way that we used to talk about it was, if you talk about somebody being in trouble at school, in detention, as we say. Why are they in detention? Because they didn't follow the rules. So anything that's in brackets doesn't follow the rules, and it goes by the different sign as far as that's concerned. Now the radius is going to be r. Now notice that the right side of the equation is r squared. So if you want to find the radius, you have to take the square root of what's on the right hand side in order to find it. So we're going to first talk about Form 2 and how to look at it and get the information about the circle that we need to find. For example, find the center. Now I'm going to spell center the way you guys do. That's kind of backwards for me. We spell it ER and not RE. And radius for the following circles. So we're going to take x minus 2 squared plus y plus 5 squared equals 16. Now which form is that equation in? That equation is in graphing form, Form 2. So when you're finding the center and the radius, remember I told you that insiders lie. The x coordinate comes first, it's positive 2. The y coordinate is negative 5. And then the radius, is the square root of 16, which is 4. So if you were to graph this, just to show you real quickly what this would look like. You would go to 2 and negative 5 on your graph, put a dot right there, and then you would go 4 in each direction, 4 up. My graph doesn't go down far enough. Let me go modify that. You would go 4 down, 4 to the right, 4 to the left. Now, in order to make your circle look circly, I found that if you draw kind of a forward C and then a backward C, and instead of trying to connect all 4 dots at once, I accidentally drew this wrong, so that's close enough. So that's the idea of what it looks like. You won't be asked to do any graphing on yours, but I just wanted to show you how the information off of your problem transfers into a graph and how it looks. So let's write the equation of a circle with center of -9, 0 and radius of 8. Okay, first thing I'm going to do is write the graphing form down. X minus h squared plus y minus k squared equals r squared. The center, remember, is your h and your k, and the radius is your r. So now all you have to do is put those values in. Be careful of your signs. When you substitute -9 in for h, you're going to have x minus -9, which becomes x plus 9 squared, plus 0 goes in, you will have y minus 0, which you can just write as y squared, equals r squared. We take the 8 and square it, we get 64, and you're finished. All right, now we need to talk about how to change from general form to graphing form. Because if an equation is in general form, it's really hard to see immediately what the center and radius are. The method that we're going to use is called complete the square. So let me show you an example of how this works. We're going to have the problem x squared plus y squared minus 12x plus 2y plus 16 equals 0. That problem is in general form. Now, if you're given a problem in the homework, and there are a few like this that are not in general form, you need to put them that way first. You need to have the x squared, then the y squared, then the x, then the y, then the 16. Make sure you have it in this order. So here's my method for completing the square. We're going to take the two terms with x's and we're going to put them together in a bracket, but we're going to put a blank at the end like so. Then we're going to do the same thing with the y's. So we have x squared minus 12x plus something, plus y squared plus 2y plus something. And then we're going to move the 16, the term without an x and y, to the other side. It will turn negative, and we're going to put two blanks on the other side as well. Our goal is to turn this problem here to make it look like this. Now, this is what we call a squared term. It is x minus a number squared. So we have to figure out how we're going to take this problem and turn it into this right here. Now what we want to do is we want to factorize this in a way, or create a factorizable problem, so that when we're done, we're going to have matching brackets. We're going to have the same thing twice. We're going to have an x here and an x here, and then we're going to have x something squared. So the numbers that go here on the ends have to be the same. Now we're going to add this extra step the first time. I think I'm going to do 2 of these so you can see what we're dealing with. The two numbers that go in the end of a factorizing problem have to add up to be this number here. What two numbers that are the same add up to be negative 12? Well, that happens to be negative 6 and negative 6. And so this is going to end up being x minus 6 squared. Now, what number has to go here so that when I remultiply this out, it will create this right here? So that would be x squared minus 6x gives me the minus 12x. What do these two terms multiply to be? They multiply to be 36. Okay, since I'm adding 36 to this side of the problem, I have to add 36 to the other side. All right, let's do the second bracket. These two have to be the same. plus 2y. So, what two numbers that are the same add up to be 2? Well, that happens to be 1 and 1. So this will be y plus 1 squared. When you re-multiply out these two brackets, what is that last term going to be? What does 1 times 1 equal? It equals 1. So we put a 1 right there. If you notice now, this bottom line right here matches the formula up here. All we need now on the right-hand side is what it equals. So negative 16 plus 36 is 20, plus 1 is 21. And we have now changed our general form into graphing form. And we can now tell what the center is and what the radius is. Now, let's practice again. What is the center? Take a look at this, and remember, insiders lie. It's going to be positive 6. Whoops, I'm writing with my highlighter. The other one is going to be negative 1. The radius is not a perfect square, and that's okay. It is the square root of 21, which you can estimate in your calculator if necessary. Let's try another complete the square problem. X squared plus y squared plus 24 equals 10x minus 6y, and that will work great. Now, is this in general form? The answer is no. So we need to rearrange the problem and put it in general form first. X squared plus y squared minus 10x plus 6y plus 24 equals 0. The 24 did not change sides. Okay, first step. Bracket the x's. Make sure you put in your blank. X squared minus 10x plus blank plus bracket y squared plus 6y plus blank equals. The 24 moves over. It turns negative. Add the two blanks to the right hand side. Okay, I'm going to go ahead and add this extra step in. You may understand it well enough that you don't have to. So we put x here and x here. The two numbers that go here and here have to be the same, and they have to add up to be negative 10. What will they be? Negative 5 and negative 5. So this will be x minus 5 squared. This last term here is always these two numbers multiplied together. Negative 5 times negative 5 is a positive 25. Now you may have been wondering, why do I always put a plus here? Because you are multiplying the same number to itself, it will always be a positive answer. So now we're going to do the second bracket. I'm going to stop for a second. I want you to try it yourself. Pause the video, see if you can fill in what goes in those two. Then when you're done, turn it back on and see if your answer agrees with mine. All right, the two numbers, the number that goes into all the brackets is 3, the blank is a 9. But I forgot to do the other side, so whatever you put in the two blanks on the left, these two numbers here, they must also go over here to keep your equation balanced. So 25 goes here and 9 goes here. So now we're ready to write our final answer. It's going to be x minus 5 squared plus y plus 3 squared equals negative 24 plus 25 is 1 plus 9 is 10. And now we are in graphing form. What is the center? What is the radius? Take a second, see if you can figure it out. The center is 5, negative 3, and the radius is the square root of 10. All right, that is the end of this lesson. Your assignment is in the Griffith book. We're going very back to the beginning. This is section 1.1, which is on page 6. For the Delta book, we're going back to the beginning of the Delta book too. It is section 1.02, which is on page 8. Please omit 10 and 11. Only do 1 through 9. But you really need to do all of those to get some practice of the completing the square in as well. If you have any questions, please let me know. and I will see you in the next video.